Hey, what's going on, folks? It's Mike here, and welcome to the programming language series First Impressions, in which we look at a programming language for the first time, or maybe a language that I haven't seen in a long time. And today I finally get to make a joke at the start of this series and ask you, what is a pirate's favorite joke? It is indeed R. Of course, the pirate language here, R programming language here. So, I had to do that. So anyways, we're going to go ahead and take a look at the R programming language, which if you don't know is a statistical programming language, or rather I should say it's a language that a lot of statisticians use. So looking at the Wikipedia programming page here, we could go ahead and see that the different paradigms we have are, well, it is multi-paradigm. It does things with procedural, object-oriented, functional, reflective, and imperative, and array programming. Okay, so we have looked at some languages that have this listed, maybe array programming, but, well, we're going to find out we're working with various types that are suited for this type of thing, like a vector or a long structured piece of data. Okay, so anyways, how R was started, if I zoom in here for a little bit, well, by these two professors, Ross Ika and Robert Gentleman here, as a programming language to teach introductory statistics here in the University of Auckland. So again, inspired from the S programming language, which interestingly I haven't actually heard of or looked at here. Maybe we should open that up in another tab, but it looks like it could run these programs as well in R. So maybe something else for you to explore on this journey if you like R, but R is certainly one of the more programming languages, more popular programming languages. So again, these metrics aren't really, always meaningful here, but again, we can see R is a language here in the top 20 of programming languages for whatever that's worth. I know a lot of scientists, for instance, who use the R programming language, maybe folks who weren't previously software engineers, but needed to pick up a language for doing some data analysis, statistics, etc., some visualizations, which I know R is great for. And this is their tool here. It gets the job done here. So anyways, you can kind of read through this here. And the cool thing is, R is a language that's been around for 30 years now at this point. So again, it's quite mature, it's quite stable. There's lots of R packages to do interesting things. As I mentioned, there's probably a visualization for pretty much everything. So again, it's used for a lot of data processing. You can see some of the plots here and so on. I know there's also a lot of interesting work with the R compiler, such as, let's see, there's a few notes here, for instance, making are available on the JVM, Java Virtual Machine. I think there's been various compiler optimizations that have been done here. And I believe it's a dynamically typed language here. Let's see if it says here. Yeah, dynamic typing for the language. So this is going to be interesting for us to look at here. All right, so let's go ahead to the R project page here. Let's go ahead and start there. So let's see if there was a link here. So the second link here. And R project for statistical computing. Okay, so it's a free statistical programming environment for computing and graphics. Compiles and runs on a variety of Unix platforms, Windows and Mac. So pretty much for everybody here. Let's go ahead and download R here from one of our mirrors. And let's see here. Where can we download? Download R for Linux. I'm on Ubuntu. And okay, we could just install this from our package managers here. So we can go ahead and compile this, and it's pretty much is all we need here. Then install the R base here. And if we want a bunch of different packages, we can do this. Now, I don't know if we're going to necessarily need to do this for this particular lesson, but let's just go ahead and let's run through this, and then we'll go ahead and take a look at R. I have installed R previously. I just haven't used it in a long time here. And by a long time, as this is installing, I mean that's been like, at least 10 years for me or so, or maybe even maybe it was even less than that. Maybe it was like 7 or 8. But the point being that I had to learn R and actually teach it to some scientists at one point here. And basically what happened is, well, I had to teach some scientists, some people who knew no programming, a little bit about R. So what was kind of interesting is that I was teaching that lesson for R programming. And I gave myself about 5 or 6 hours to learn it ahead of time so that I could teach them and show them some interesting examples. So again, it goes to show, as we're doing in this programming series, that once you learn one language, you kind of know many languages, or at least can think like a programmer, can think computationally. But that said, every language, every tool has its advantages, and R, of course, is used for various statistics things. So this gives me a little bit of an advantage because I do know one thing about R, and I know RStudio, which I've got set up here. Let's actually go back here. Let's go back to search. If you search RStudio, there is this free desktop tool here. So I'm probably going to play around more in here. Let's actually download and install this here. Okay, so we've got R downloaded. But let's go ahead and download RStudio. And I think even though I'm on Ubuntu 18, I'm able to get away with just installing the 20 version. And we can just sudo and do dpkg-i and install that package here. And then, of course, if you're following along on Mac or Windows, you can just do that. So anyways, I should have R, that's capital R here, and that'll launch things here. And Q for quitting here. I don't want to save the workspace. So let's learn a little bit about the R programming language, and then we'll maybe dive into some more examples here. So let's see. So about R here, well, we learned a little bit about it. Interestingly to see that the S programming language is something also developed at Bell Laboratories. Now, Bell Laboratories was, of course, famous for developments in C, Unix, C++, and so on. So really some interesting stuff there. Okay, by John Chambers and some colleagues here. And it's just considered, R is considered a different implementation of S. Okay, so that's kind of interesting to see this evolution here. I think most people know R. I know of it, and again, have used it one time exactly, but maybe not as many S here. So that's kind of interesting. So I'm going to be really curious to see if we can get into some statistical methods or maybe graphing some things out here. That could be interesting here. Okay, so maybe we'll just learn just a tiny bit here. Now this is also interesting just to make a note here that we can link in C, C++, Fortran, and other code at runtime. Okay, so that's a good thing. There's some interface to do that. Again, if you've either got a lot of code and maybe you want to utilize R for maybe the visualization or again the statistical analysis, maybe there isn't a package for that, or it's more convenient to think in R, that's useful. And then we've got these, let's see, I don't know exactly how to pronounce this, CRAN or CRAN packages. So let's see here if they give us an acronym. I'm sure they will at some point. Or maybe I think actually download the Comprehensive R Archive Network. Okay, so that's the CRAN. There we go. And we'll download some of those packages if we need them. What's going on here? Looks like there are lots of messages. There's an active messaging board here. Conferences. This is pretty cool here. Again, I always kind of look and see if there's interesting conferences or these types of things going on. Again, I think it's just healthy to know that the language, there are experts that you can talk about. You can go there if you're really interested or inspired here to see some cool talks. And let's see, we've got the use R. Okay, there's a forum there, something DSC, platform for developers of statistical software. Okay, so lots of cool stuff here. Lots of different things going on here. Okay, so great online community. It looks like there's been conferences all over the world. So again, you know, if you really like using R, you can check this out here. It looks like it's also directions in statistical computing. That's what this DSC is. Different types of conferences here. Okay, so they've got a pretty lively community. Lots going on here. That's great. And folks can get involved. They can contribute. Oh, this is even great. You know, seeing stuff on YouTube, like how to build videos, you know, whether these are coming from conference talks or contributors. Again, always nice to see from the language here. This is kind of cool. The R journal here, a peer-reviewed open access scientific journal published by the R Foundation. Hey, that's pretty cool. Short to medium length articles covering topics of interest. That's probably the first time I've seen this for many of the programming languages that we've looked at, that there's a journal here. I think that's pretty cool to see that you can, again, as an academic or a scientist, this is useful for just disseminating your work for other folks to benefit from. And, you know, for you to find collaborators and so on. So that's pretty cool. That is something worth citing here. Again, we're looking at different program languages, but also sometimes they have different ecosystems that they're involved with. And of course, there's a plethora, many books here as we're scrolling through here. Again, another nice thing to know when you're diving into a programming language. Can you get help? Especially if you're new. If you're an expert programmer already and know that you need this for statistics, you know, you'll figure it out. But let's go ahead and see if we can have our little tutorial here. Okay, we've got getting help with R. We've got some manuals here. Let's go through this introduction here. Yeah, let's do this here. And okay, so we got a lot of stuff here. I actually like that this is just a giant single page here. I can do Control F and find cool things. Okay, and we already know a little bit about S. Oh, and S plus. Okay, there's all sorts of programming language variants here popping up. But let's look here. The R environment. Okay, so let's look at our R environment. Capital R on Linux here, 4.3.2. Useful for data management and wrangling. That's giving us the idea here. Let's just go ahead and type out some programs, and then we'll look in RStudio and see what we can do here. Now, it's kind of interesting here, just diving in. Our introduction to the R environment did not mention statistics, yet many people use R as a statistics system. So again, sometimes you gather a reputation in a language, so that can't be escaped. So I apologize for even, starting off with lots of people use this for statistics, because that's, again, how I know of it. So its reputation is for a good thing, but they prefer to think of it as an environment with many classical and modern statistical techniques that have been implemented. Okay, and then you've got packages, and I'm sure you could write whatever software you want in this tool. It is a, Turing complete language, so that's fine. Okay, so let's work with R interactively. We should probably make a directory somewhere. Let's see, make directory R, YouTube, that's where we are right now, so welcome. And let's go ahead and launch R, Q to quit, as we have seen here. Okay, so let's go ahead and do some stuff here. Let's see, okay, so we can help and solve. Okay, so we've got solve a system of equations. Oh, this is neat. Generic function to solve the equation A times x equals b for x, where b can be either a vector or a matrix. Okay, interesting here. So let's see. Arguments, a square, numeric, or complex matrix containing coefficients of a linear system. Well, that's a pretty powerful function, something handy to have. Interestingly, I mean, since we're thinking about these things as, system of equations, so any number of parameters, right, where I see solve A, B, I wonder if this is how you specify like a variadic function here, where you can take any number of A, B, C, etc. To actually solve here. So that's kind of neat. And again, that's think about this as you pass in a vector, so a series of equations, and solve for this. Okay. Okay, and it gives us the whole help system on the last page here. Q to quit here. Alternative. Okay, shortcut for help. Okay, like the built-in help, that's always super useful. Let's see. And for features specified by special characters, arguments must be enclosed by double quotes. Okay, so I can search for things like, I guess we'll find out in the language what the brackets mean. Yeah, that's kind of useful. Very neat. Okay. So that's useful for us. And most R installation help is available in HTML format. Okay, so we can launch this in a browser or something. Okay, which is where we already are. And the help search command allows searching. Okay, let's search for solve. What does that do? Oh, this tells us all the different ways to solve. Okay, great. I like this. Python, for instance, in the interpreter, I use, help exactly like this all the time. This is useful stuff. You don't think about it now when you're on the web, but if you're in an airplane or traveling a lot on a train ride, these kind of things are nice. So, okay. So let's do a little bit with R here. Okay, expressive language. It is case sensitive. Okay, most languages that I use are. So X is different than capital X is the idea. Okay. Okay, so let's kind of keep going through here. Let's see if we can do some commands. Okay, if we have a external file, we can use source. That's a Linux thing. We should sort of be used to that. And sync. For Windows, source is available on the file menu. The function sync will divert all subsequent output. Oh, that's kind of cool. I mean, let's see. So that evaluates. I'm going to kind of break this sync output.txt here. Okay, so now we're writing out to this output file. Oops, let's quit here. And look at our output. We should have, whatever our output is. Again, that's going to be very useful for data processing. It's also just a useful thing for, even for your functions. Again, I sort of think in languages like C++ or D or whatever. You can even have sources and sinks as arguments into your functions for where you should write out characters, or like buffers of data, for instance. It's not a bad methodology to use here, right? This sort of Unix idea of piping data along. It kind of works well. So kind of neat to see that they just have that built in their interpreter. Again, you can usually output standard out in many different ways, but that's kind of nice here. Okay, the command, okay, sync, so that's good. That just restores it to the console. Okay, or standard out, whatever here. Okay, data permanency and removing objects. Okay, so I can just type out objects here. Well, let's see here. If I do like a equals 1, then objects. Okay, so then I have all my objects here. There's b. Okay, makes reasonable sense here. Make that a little bit bigger for you just so you can see. Okay, so we got a way to kind of query what's going on, and we can remove these. In parentheses, A, B, and then our list is empty. Okay, cool. Interesting. Objects are written to this file are data, and we have our history. Okay, some interesting stuff here. All right, let's get into some statistics here with some manipulation, numbers, and vectors. This is what we're here for. This is what R is known for, so kind of interesting stuff here. Okay, now this is already interesting just looking at this for vector assignment. And again, we're going to do C here, which is, let's see here. Okay, yeah, we've got this ordered collection of numbers that I'm assigning to X here as C collection. Let's see. Is that the way to think about this? Using the function C. Well, we can use vector arguments. Okay, by concatenating its arguments to the end. Okay, well, we'll use help in a moment to see what's going on here. 10.4, 5.6, 3.1, 6.4, 20.7. Okay, and oh, okay, so if I type in C, that just tells me it's the function. Help. This is a generic function which combines its arguments. Okay, so this is concatenate effectively. Okay. And X is where we stored things. Okay, there's our values. And can I index into them? X at 0. X at 1. Ah, okay. This is a one index language here. Okay, as we're playing around here. So again, kind of neat here how that works. So a few different things here. The assignment operator from the right side to the left. That's the first time we've seen that. And I wonder if I can use the other side here. Oh, answered my question here in the help already. Okay. Some neat stuff there. And then, of course, one index language. Okay, cool. Some neat stuff here. Let's go ahead and see some of these arithmetic operations here. And at this point here, it might be kind of neat is to launch RStudio since we're getting into, more interesting stuff, which, again, I installed already. But let's go ahead and bring this in here and go ahead and kind of repeat the example, I suppose. Now let's see if this is big enough here. Let's go ahead in the editor or the view. Tools, maybe global options. Let's see here. Let's make the display just a little bit bigger for you folks. Maybe it'll be too big, but there we go. Just so you can see what we're typing here. And Control L is what's clearing the screen here. Okay, so let's try that example here. So I'm going to assign X to concatenate 10.4. Can I just use spaces? Let's see if that... No, okay. An up arrow, okay, gives me back my code here. 6, 5, 9, okay. Now this is the cool thing. I just noticed something in RStudio here. It's got my objects list here. So the same thing that I was typing out there, I can just see it. I'm assuming I can just remove it if I call the right function. Yeah. And that's my environment. Okay. And I can just hit up to place that back in. That's pretty cool. Interesting here. Now what if I type out solve here? Help, solve. Okay, and that's going to search here. Okay, so really nice job. Nice layout by RStudio here, integrating some of these things. We've got the help page here. Looks like I got my plots and files and where I currently am, right? That little output file that I had here. So RStudio is pretty neat. We've got everything set up and it's neatly organized. Let's see if we can, we can even put together presentations of data or something. Okay. And just, oh, it looks like I need to download some packages by just clicking on them. Brilliant. They've got a parallel package. So again, usually we look at the standard libraries of these different programming languages, which is useful. But anyways, let's look at a few more examples here. Let's see what we're doing here with vector arithmetic here. Okay, vectors occurring in the same expression. Okay, they don't need to be the same length. Oh, interesting here. Okay. If they're not, the value of the expression is with the same length as the shortest. Okay, if they're not the same length, the value of the expression is a vector with the same length as the longest vector, which occurs in the expression. Okay, so they like truncate them. Shorter vectors in the expression are recycled as often as needed, perhaps fractionally, until they match the length of the length. Oh, okay, so they're sort of updating here. Okay, it's giving me a... so with above assignment, let's see, whatever this command was, where I put stuff in X. Did I put anything in Y? Oh, we should put, oh, now Y we're concatenating. C with X, 0, X. Okay, so we're going to see a 0 in the middle here of whatever this value is that I put here. And then let's go ahead and use this arithmetic here. Let's just go ahead and paste this in here, make sure we don't mess anything up. Oops, maybe it doesn't want to paste here. Oh, there we go. Warning, longer object length is not a multiple of shorter object length. Okay, so it's giving us a warning. It is trying something. Let's see what it actually put in there. Oh, that's it's showing us the first 9 elements, and then, oh, I guess this is starting from 1, so this must be 10 and 11 here. Okay. 1, 2, 3, okay, etc. So 2 times x, we're multiplying x plus y plus 1. So let's see here. 2 times 10.4, 20.8 plus 1, 21.8 plus our y value, which is another 10.8, so that gives us the 32.2. Okay, kind of interesting. I mean, this is sort of an error, right, to evaluate this expression, but it is proceeding by basically just ignoring the y value. That's what it looks like here, if I understand that correct here. So we get to, let's see, 1, 2, we have 1, 2, 3, 4, 5 values. 1, 2, 3, 4, 5 values are correct, and then we get 21.8, which is basically just doubling 10.4, adding 1, and then y is just 0 or something. Okay, so it's just treating it as 0, I guess. Okay, but it gives us a warning. I wonder if there's a way to like detect that, right? Can we fail? I don't want to evaluate that expression, so maybe there's some way to be more strict about that. But of course, when doing data processing, right, you're not always going to have clean data with vectors, right? You might have some holes in the data, so that'll be kind of interesting to take a look at. See how we handle that issue here. Okay, some statistical functions here. Mean, we've got sum, we've got length, and var, which is variance. Okay, so let's play around with this. Let's take the mean of x here. Let's take the median. Okay, I just started typing stuff in. Okay, that's kind of cool. Can I just sort things? Yes, I can. And that doesn't modify my actual value here. Okay, so I mean, this is where we have the fun. I mean, these are just functions I use in Excel or the Google Docs, Google Sheets, whatever version. And let's see, variance. Yeah, and these are the types of things where if I'm building or writing a program in some other language, I just want to run these. And if I'm doing statistical analysis, I just want to, like check out a value really quickly and, be able to run through my data and compute something. Let's see here. Do they have like, I don't know, like a derivative or something? Symbolic. Okay, derivatives of simple expressions. What's derive 3? Let's see here. Well, what is it? We can ask. Derivative 3. Derivatives of simple expressions. I mean, this is kind of cool stuff. Again, these are all the things that I want in, some of my languages when I'm doing graphics work. We use all this stuff here. Yeah, it's kind of cool here. Yeah, it would be a fun little program to do, is just to look through R and pick out a random statistical function or something and, be able to read the help page, run an example. which actually, let's not forget about what we learned here. Example, deriv 3. That's just going to run through it. Okay, now we got tons of examples here. Maybe not the ones we want here. How do I undo this? Last command. And maybe I can reload or do something here. But yeah, it's kind of interesting here. Okay. So we can see all these things. Again, that's neat to just be able to run the examples right in the in RStudio, so it's supporting that. That's kind of what I want to do too. I kind of want to look through a manual page like this, right? And sometimes not just see everything. I just want to, know how to use it. And I wonder if I use usage. Oh, interesting. Usage could not find function. Okay, USRS. Oh, okay. Uh-oh. Hey, let's find something more positive later. Maybe. Okay, so there are some built-in data sets. I do remember that here. Okay. Maybe they'll give us something here. Okay, let's look through some of these sequences here. Oh, interesting. Okay. So this is going to be useful for generating. In different programming languages, we've been really excited by using like iota, for instance, but I mean, maybe we should just call these, sequence like this. So generate a sequence from 1 to 5 by, 0.2, and there you go. We got some data. It's already sorted, so we can just combine it like that. Let's find the minimum element. That's probably there. Let's take the average. Let's see what else they got built in here. Oh, right, mean. I guess there's going to be different types of means, though. Okay, some other stuff there. Okay, but anyways, yeah, we get the idea. Yeah, that's pretty neat. So we've got some ways to generate data, right? In Python, you're using range. Other languages, you might be using iota. So we just generate a sequence of numbers. I actually like that. And okay, we've got a replicate here. Okay, so let's put some of these together here. Let's generate a sequence from 1 to 5 here. Let's do by 0.5. And R is the argument here. Let's see here. Got to switch back and forth. Oh, rep, whatever the value is, and then times. So that's going to be my value, and then times equals 4. Can I do it like that here? Could not find function R. Okay, rep. There we go. Yeah, quite nice there. So already, I mean, this is a nice tool for quickly generating some data here. Nice. Okay, so let's kind of keep powering through this. Let's see if we can get to some graphs and stuff here. So let's kind of take a look through our table of contents here. We've got some data that we can play around with. We can sort of change the length. We've got ordered and unordered factors. Let's take a peek through some of this here. Okay, let's see here. Well, I wonder if there's a states data here or something. Ah, okay, there we go. State names. Okay, there we go. Hey, we have some data here. So now we can sort them. Okay, very interesting. I wonder if I can sort decreasing. Okay, I just did comma and tabbed. Decreasing. True. Oh, and it helped me out there. And that reversed them. Okay, cool. Just kind of playing around with this randomly, and we could figure out stuff. That's kind of nice. I mean, this RStudio is really nice. And it's completely free too, which is great. Okay, so anyways, let me keep kind of scrolling through this. Function t apply continues previous example. I think we kind of get the idea here. Basically, what I want to do is look at some matrices and then maybe graph some data, and then we'll call it a day with the R programming language. But this is, when I look at R, I'm also thinking about my days using MATLAB. which is another one index-based language with various graphing properties. Again, very powerful for engineering applications. That's probably the bin it falls into, or that folks default when they think of MATLAB. R for statisticians. So kind of interesting stuff here. Okay, let's see here. Arrays and matrices. Okay, arrays are collections of data entries here. Vectors can be used by R. Okay, the dim attribute. Oh, haven't seen that in a long time. My basic programming language used to use that. Okay, but what does that do for us? K-dimensional. Okay, let's just look for some examples here. Okay, so we got a few. You can concatenate these. Let's go ahead and pop this in here. Oh, we need the object A. Uh-oh, I skipped something. Okay. Oh, continuing the previous example. Jumping around here just a little too much. Sorry about that. For example, is... Okay, this is just populating us the dimensions here. Let's paste it in here. Oh, forgot something, so I get that plus. Oh, but I'm missing the object Z. Uh-oh, really falling behind here. Sorry for skipping. That's what I get here. Oh boy, let's see. How do I get this working? Yeah, you can't skip stuff, I guess. But I still want to look at some examples because I think we're getting the sense of the programming language, right? It's, you know, generating matrices and vectors and doing some cool stuff with them. But let's see if we can generate a plot here. Okay, let's start with, yeah, this is bringing back flashbacks of my MATLAB day. Maybe that's another first impression that we'll have to do here. Okay, here we are. Here's X. And beautiful. Okay, so from 1 to 20, and okay, so this is the range here, and here's the dimensions. We get some data here. Cool. Simple enough here. Okay. I wonder if we can plot this. Again, just doing random stuff here. Now, if I just pass in X, well, it's a two-dimensional thing. Oh, brilliant. There it is. Okay, here it is. Let's see if we can interpret this. I mean, I've basically achieved my objective here at this point. What I want to see here. And now it's going along the diagonals here. What are we actually plotting here? We've got 4 by 5. What have we done here? Let's see. We've just kind of plotted along. Let's see. X comma 1. So that's this first, our columns here and our rows. Okay, so I kind of just picked something out here. Yeah, let's see if we can get something interesting here. But this is starting to get interesting just for populating our arrays here. I actually like this. These would be nice things to have, and these are things you could extract and put into other programming languages. Again, one of the reasons or points of this series is to look and see how we do other things in programming languages. And if you don't have this feature for generating or making an array, you can, you know, write the library here that takes in a sequence or an iota or a range or whatever it is, specify the dimensions, and then just have it populate this automatically, right? You can write this function. There's no problem with that. So that's kind of neat here. Okay. Let's see. I get some less trivial examples. Okay. Okay, and we can do some other interesting things like start taking the outer product here. Okay, so there's some different symbols for that. Okay, so it's got its own syntax here. Transposing arrays, right? All the different matrix operations, matrix multiplication if they're square. The matrix of elements. Oh, you could do element by element products if you want. Okay, but surrounding with the percent signs. Okay, so some different operations that we could do here. Yeah, let's kind of scroll through here. Eigenvalues. Wow, this is great stuff. Great for you know, as a graphics programmer, you probably want to learn one of these tools well, whether it's MATLAB, Mathematica, R, like we're looking at, so that you can test and, you know, see some of these functions here. They're also very nice just for using, you know, as examples, for instance, in visualizations, what the different operations are doing, you know, to be able to just generate some data. So that's kind of cool here. Partitioning, concatenating, frequency tables. Yeah, interesting here. Okay, let's do that table. I think this is where I get some data here. Let's see here, table, states. What did we have here before? By area. Okay, there we go. Now, what exactly is that showing me? The areas of each of the states here. Let's see here. Suppose, for example, okay, frequency. Okay, frequency. Wow, that's pretty easy. Okay. Interesting. State area. Okay. Okay. And then they've got the like tools and such for like Linux on the command line. You can use things like cut and so on to trim away the data. Okay, so that's pretty neat here. Okay. Very cool. Very cool. Let's see what else here. Let me just briefly look at the table of contents here. And let's see what other examples they've got here. Reading data from files, okay, probability distributions, grouping, looping, and so on, writing your own functions. Okay, let's see how to do that. Let's get an idea of the syntax here. Okay, so that's going to be the function name, and it's curly brace language here. Let's write a little function here, add or something, x and y. Oops, let's see, maybe I didn't do that quite right. Oh, if you hit enter, it probably enters it in all in. Okay, let's try that again. Function. If I do add 1 and 2, okay, it doesn't return anything. What value does it return here? Is it the last value? Simple examples. Okay. I guess it is the last value there. Some languages do that. Add function x comma y. Let's see, shift enter. I'll be very careful. X plus y, and then a right curly brace enter. Oh, let's see. What have I done? Try that. Unexpected curly brace. Okay. I do have an extra one. There we go. Okay. Add 5 and 6. Okay, great. So we get a value here. Add. Now, can I just use x here, whatever that is? Yeah, it seems like I can do that. X times 2. All right, neat. And x, well, let's see what our object was just this range or this array that we downloaded. Alrighty, and that is our camera telling me it's about time's up here as we sort of go through this. But I think we get a nice idea of what the language is doing. Now, really cool, again, in RStudio, clicked on X here, and we can already see, it's plotting the data, it's giving us a view, and so on here, okay? So there's probably lots of nice and interesting packages. So if you enjoyed this sort of, dive into the R programming language, let me know. Then we could do like a more serious, series through this and actually look at some packages. Let me know what your favorite packages are. We can do some better visualizations of the plots, maybe do something more meaningful and put trend lines in or do stuff in 3D or whatever. But again, I think it is useful to see some of these different statistical languages here. Now, actually, really quick before the camera goes out again, let's see if there's any other things that we missed that could be very useful here. Probability distributions. I wonder what the probabilistic programming capabilities are. That'd be something that'd be interesting in learning about here. Now, certainly if you have different mathematical functions that can generate interesting distributions, that can be very useful for you. Yeah, we saw the periodic arguments, okay, scope, and then we get into a whole bunch of statistical models, which is, again, probably beyond what I'm prepared for a first dive into a language to know about. We've got our plot commands here, so, everything that we can do with matplotlib and Python, but easier, probably, or maybe different visualizations. I mean, that again is what R is known for, working with these various statistics here. Okay, so lots of cool stuff with the R programming language. Hopefully you enjoyed this reintroduction for me after, again, as I mentioned, well, I don't know, somewhere between 7 and 10 years since I've looked at it. But I do think RStudio is a really nice integrated development environment, lets you rapidly prototype, play with data, see what's going on, ask for help. And that's insightful for what I think a tool should look like. So anyways, folks, with that said, I hope you enjoyed this brief investigation into the R programming language. Maybe if you are a scientist or somebody who needs to do some data analysis, you'll consider looking at this tool. Again, maybe it's not your day-to-day programming language for software development, but it could be useful for data analysis, dumping data into this format and generating interesting plots and graphs and so on. Anyways, folks, with that said, thanks for joining me. Thanks for your time, and I'll look forward to seeing you in the next one.